Grade 8 Math number 7.1c, write a linear equation from a description. Have we said in the last couple of videos that equations with the variable on both sides, with an x on both sides, can be used to compare prices or costs of real-life situations? And to solve these equations, we use inverse operations, opposite ones, to get the variable terms to one side of the equation and the constant term on the other side. So variable term is a term, and terms are separated by operation signs, so that's a term and that's a term. And this is a variable term because it's got a variable in it. This is a constant term because it's a constant that's not going to change. And do you remember what a coefficient is? It's the number in front of the variable. So this 3 and that 8 are coefficients to the x or to the y. And that means we're going to multiply by whatever that variable is, right? All right, so the inverse operations are, if it has addition, we use subtraction, and if it has subtraction, we use addition. Those are the opposites of each other. If it has multiplication, we use division, and if it has division, we use multiplication. Those are opposites. Inverse is opposite. We can write a linear equation to represent a description and then solve for the variable. So if we have 2 less than 5 times a number, then that means we've got 5x minus 2. It's 5 times a number and 2 less. 5x minus 2 is the same as means equals the number plus 10. So it'd be x plus 10. So we've got 5x minus 2 equals x plus 10. We subtract x from both sides, from this side and from this side. This positive x and minus x cancels out and creates a 0 pair. This one is taken from 5x and becomes 4x. Now we've got 4x minus 2 equals 10. We add 2 to both sides because this is a minus 2. We add 2. The negative 2 and the positive 2 create another 0 pair and cancel each other out. This 10 plus the 2 makes a 12. And now we've got 4x equals 12. We divide both sides by 4 as an inverse to the 4x, which is multiplication. 4 divided by 4 creates our friend, the invisible 1. So now we just have an x here. And 12 divided by 4 is 3. X equals 3. See? We slowly had to do it 3 times, didn't we? An inverse operation to isolate that one. So now we know that x equals 3. Let's try it with this one. A number increased by 3, so that would be x plus 3, is the same as, that means equals, 24 minus 2 times the number, 24 minus 2x. So the first thing we do is we're trying to get the variables to one side. So because this is a minus 2x, we can add 2x to both sides. When we do that, this creates a 0 pair and cancels out, right? And we add 2x to this x. And remember, there's an invisible 1 here. So that means we have 3x on this side. 3x plus 3 equals 24. Now, we need to subtract 3 from both sides because this plus 3, we can do a minus 3 and get rid of this. We can cancel this out. So now we subtract 3 from this side, we get 21. We drop the 3x and we have 3x equals 21. Now we can divide both sides by 3 to get this x alone. And 3 over 3 equals 1. There's our friend, the invisible 1 again. And we have x equals 21 divided by 3 is 7. X equals 7. See? Again, we did 3 inverse operations and got the variable by itself. Okay? Let's try it again. We got another example. 12 less than 6 times a number. Well, here's 6 times a number, and this is 12 less than it. 6x minus 12. 12 less than 6 times a number is the same as, that's equals. So here's our equal sign. 2 less than the number. So it's the same number, it's just 2 less. So we have x minus 2. So now we can subtract x from both sides. Because this is a positive x, we can subtract x. And that's going to create a 0 pair, isn't it? And cancel out. 6x take away 1x is going to be a 5x. Because remember, there's an invisible 1 here. If you have 6 x's and you take an x away, that's 5 x's. So now we've got 5x minus 12 equals negative 2. Well, because of this minus 12 here, we can add 12 to both sides, create another 0 pair. This will cancel out. And now we add 12 to this side. Minus 2 plus 12 is a 10. See, it brought us out of the negative to a 10. Now we can divide both sides by 5 because we've got 5x equals 10. 5 over 5 makes our invisible 1, so we've got 1x. 10 divided by 5 is 2. We know x equals 2. See? Again, we did 3 inverse operations, and we were able to isolate x to one side. Here's our last example. We have 4 more than 8 times a number. Well, here's 8 times a number, 8x, plus 4, because it's 4 more than 8 times a number, is equal to, well, there's our is equal to, 10 times the number minus 6. 10 times that x minus 6. So the first thing we're going to do is subtract 8 from both sides. Here's a positive 8. We can put a negative 8 on each side. The positive 8 and the negative 8 are going to cancel each other out. And this 10x minus 8x is going to be 2x. So now we've got 4, because the 4 dropped down, equals 2x minus 6. So because we've got this minus 6, we can add 6 to both sides to cancel this out, make a 0 pair. Minus 6 plus 6 makes a 0. And now 4 plus 6 on this side makes a 10. The 2x drops down, and we've got 10 equals 2x. Now we can just divide each side by 2, because that's a 2x. The opposite of multiplying 2 times x would be dividing. So that's why we divide. And the 2 over the 2 makes a 1. We make our friend the invisible 1 in front of the x. 10 divided by 2 is 5. We know x equals 5. See? So not only were we able to write the equation from the description, but we were able to solve it using the inverse operation. Okay? We're going to talk about doing this with rational numbers like fractions and decimals in the next unit in 7.2a. See how we can do this with fractions, how we can use inverse operations and slowly cancel out fractions. Okay? I'll see you there. Bye.